All right, so in 9.3 we're going to talk about the area of composite figures. Composite means all put together, so taking figures and putting them all together. So a composite figure is made up of simple shapes. So these are our triangles, our rectangles, trapezoids, circles, yada, yada, yada. To find the area of a composite figure, all you have to do is find the area of the simple shapes and then use the addition postulate. So you're going to add them all up to find the area of the whole thing. All right, so for this first example, they want you to find the area of the shaded region. They want you to round to the nearest tenth if it's necessary. So the first thing I want you to do is divide it into parts. So we have the half circle up top. Then, if you break this apart, you have the rectangle, and then you have a triangle. So you have three different pieces that make up the whole shaded region. So to find the area of a half circle, remember to find the area of a circle, it's pi r squared. But since it's a half circle, we're going to divide it by 2. So if my diameter is 20, that makes the radius 10. So this is going to be pi and then 10 squared over 2. So we're looking at about 50 pi. All right? Then to find the area of a triangle, hopefully you remember this is 1/2 base times height, or base times height over 2. Now you're going to have to do some finagling here. If the whole thing here is 32, and up to here is 20, that makes this piece right here 12. And we know that the height over here is 14. So this is base times height over 2. So this gives you 84. And now the rectangle is just simply length times width. So this is going to be 14 for the width, 20 for the length, so that gives me 280. All right, so now, pi here is going to have to be taken care of, but if you type it into your calculator, we've got 50 pi plus 84 plus 280. It equals about, now remember to the nearest tenth, 521.1. Now don't forget your units, we're looking at millimeters. And then since it's area, it's got to be squared. All right, so this next one, again, they want you to find the shaded region, round to the nearest tenth if you have to. Taking a look at this, a lot of people are tempted to do a whole bunch of different stuff. So we've got lots of different triangles in here. We've got a trapezoid in here. I like to keep things simple. I actually see just two shapes, and it's actually quite easy to do these two shapes. I see a parallelogram whose area is base times height, and I also see a triangle here whose base times height over 2. Okay, so to find the area of the parallelogram, base is 8, height is 5, so 8 times 5 gives me 40. To find the area of the triangle, base is 10, height is 5, so 10 times 5 divided by 2 gives me 25. And now the shaded region is a combination of these, so 40 plus 25. We get 65, and then don't forget your feet squared. Don't overcomplicate this, you guys. Try to make it as easy as you possibly can. It might take a minute to actually figure out that, you know, these two shapes make up all of this together, but that's the whole part of this. That's the hardest part of actually doing these problems. All right, I would like for you to please find the area of the shaded region. Now, I want you to notice we've got a triangle here, and we have a half of a circle being taken out. So we're not going to be adding these two things together. You want to take the triangle and get rid of the half of a circle, okay? So do this problem, come back, we'll see how we did. All right, so the area of the triangle, base times height over 2, gives you 234, base times height. The circle, the radius here, if the diameter is 9, it's 4.5. So we've got pi times 4.5 squared. Now don't forget it's a half of a circle. So we get 10.125 pi. Now remember, we want to take the triangle, 234, and subtract that half of a circle. So 10.125 pi. Okay, this gives me 202.2 feet squared. All right, I would like for you to try this one. Find the area of the shaded region. Now don't forget, we have a circle, and we want to get rid of this trapezoid, okay? All right, so take a minute, find the areas, subtract them, and then we'll see if we come up with the same answer. All right, so pi r squared is for the circle. The diameter here is 20, so the radius is 10. You should have gotten 100 pi. Now for the trapezoid, remember it's the sum of the bases over 2 times height. So 12 plus 20 is 32. Divide that by 2, it's 16. Times 8, you get 128. So now you take the circle minus the trapezoid, and it's about 186.2. All right, last one, find the area of the shaded region. Again, we have the circle. The circle's easy. The circle is pi r squared. The radius here is 3, so this is just 9 pi. Okay, and now we have to subtract the square. To find the square, it's side squared, right? Now, the side we don't have. However, if you remember, a square with a diagonal through it gets broken up into two 45 90s. So if you have the hypotenuse to go back, you have to divide it by the square root of 2. So each leg is 3 square roots of 2. So this is 3 square roots of 2 squared, which gives me, 18. So now you take your circle and you subtract the square, so 9 pi minus 18, and you get about 10.3 inches squared. Okay, I told you these special right triangles are coming back to haunt you each chapter. You need to know them, you guys. Make sure that you come with questions, and we'll see you tomorrow.